Alright, welcome to Subdivision Modeling Basics. And what we're going to do in this video is not so much go over the tools of modeling. You should already know that at this point. If not, please go onto YouTube for your relevant software and search for the modeling tools. I will not be going over that in this video, although I will be showing you more or less the tools that I use on a day-to-day basis for production 3D modeling. But we'll do it through the entire process right here. So before we jump in, I want to give you a way of thinking about 3D modeling that will serve you. It will pay you dividends if you apply it in the right way throughout your career. The problem with how most people model is they like to go into details first. Meaning they like to make all this tiny, nice little detail before they even get the shape of their model correct. Now, this can be very alluring because these details look very nice to us and we just want to spend all day tweaking them, but they will not make us a finished 3D model. So instead of diving straight into details first, I want you to think about it this way. We want to start with our structural edges, and these are the edges that are necessary to present the shape of the object. And if you think about it, these details are not necessary for representing the shape of the object. So we consider this as tertiary details. We first have our structural edges, then once we have those structural edges where we want them, we will add supporting edge loops to them so that they can subdivide nicely. And once we have that base shape, then we can think about going in and adding details to it. Okay? It's very similar to when you're drawing. You're not just gonna go in and draw like the ear and make it all nice when you don't even have the perspective of the face down. This is the complete opposite way to go about it. And same applies to 3D modeling and hard surface modeling. Think about first the primary shapes, then the secondary shapes, and then the tertiary forms, which will be your details, micro details, and whatnot. So what do I mean by structural edges? Structural edges are edges that if I remove them, the shape of the object will change. So let me give you an example. Where you have our basic cube here. Why do I say that? Because this is as simple as a cube can get. If I remove an edge, the shape of the cube will change. It is no longer a cube, right? This is what we call structural edges. If I remove this structural edge, the shape of the cube changes. If I remove this edge, the shape of the cube changes. So all these edges are necessary to support the main shape of the object. If you look at cylinders, if I remove this edge, it no longer is a cylinder. And we'll get into cylinders in a bit. But I want you to think in this sense. Or, you know, if I have this curved surface. And you might be wondering, hey, if it's a curved surface, then won't every edge I remove be a structural edge? And yes, you're right to say that. So if I smooth this shape and I remove this edge, technically I just changed the shape of the object, right? So when it comes to curved surfaces, we're going to have a different mindset to it, right? We're not going to adjust. If we're adding detail to this, let's say I'm gonna smooth this, and I want to add detail to this curved surface, I'm not going to add, or I'll try not to add horizontal details like this, because that will affect how the structure looks. And you can see there's a bit of this weird bump going on. So we're trying not to add edge loops up to structural edges. The only times we can do that, and it is possible, is if we have a curved surface and we want to extrude a detail in, right? This is fine because this detail is isolated to this box right here, you see? It doesn't run up the entire length of the curved surface. And then from here, we can even adjust this edge to fit the curvature of the surface more. But more on that later. Right now, I just want you to understand that you should think in terms of structural edges, adding supporting loops, and then you go into the details. Okay? And we go more into detail on this later, but keep that at the top of your mind. So let's talk about supporting loops. Edge loops, supporting loops, whatever you call it and whatever it's called in your software. We have the basic cube here. So I'm going to tell you about a few ways that I add supporting loops, and these are the most common ways to do it and also the best ways to do it. So I duplicate my cube here, and the simple one, as you might already know, is to add edge loops to support the structural edges. Right? So these are supporting edges because they support what? The structural edges. Right? So if I remove this edge loop and I smooth, the shape will change upon subdivision, but the base shape will not change. Right? That's what supporting loops do. They change the look of your object upon subdivision, but they do not change the base shape. So this is our base shape, right? We smooth it, it comes like a circle or a sphere. But if we smooth this, we still have our cube. Because why? The cube is holding this edge in place, or these three edges in place are supported by this edge, and this edge. So, easy way to add supporting loops is with the multi-cut tool in Maya. You press Control on your keyboard, and you can just add tool supporting loops like this. So, I've added supporting loops to support these three edges, right? I didn't add supporting loops here and here, so I do not expect these edges to hold. Does that make sense? So if I press smooth, these will lose its form because there are no edges to hold it, whereas this edge is fine. You see? And here it's missing an edge here. Can you see how the supporting loops are affecting the shape of the object? And in Maya, I just have to press 3 to smooth. But if you're using 3ds Max, you need to use Turbo Smooth. And if you're using Blender, you need to use the relevant tool as well to smooth the object. So, supporting loops. All these edges, all these structural edges are being supported by supporting loops. And you can either use the multi-cut tool or the edge loop tool to add these edges in. The good thing about the multi-cut tool is you can also cut in manual edge loops, right? You can cut into the surface, manual things, which is why I love it so much. So this is the first kind and probably the most common kind you use in your career. And the second kind is fillets. So how to achieve this kind of rounded shape? Simply, I took the cube, select all the supporting edges, the structural edges, and I bevel. And I increase the number of seconds so that it will create a nice rounded shape. And I can adjust the size of the bevel based on the fraction. So the larger the bevel, the more smooth it will be, or more rounded it would be. So you have to think about this, like how, and if you bevel it too much, it starts to look like a sphere. So it depends how thick you want this to be based on the size of your bevel. And increasing the number of fractions will also help. If, let's say, I wanted to have a thick bevel, a thick fillet, then yes, having a lot of segments will help to kind of smooth this curvature, create a nice shape, right? And this I don't use that much, but you can if you want. You can experiment with it, but I don't use that too much. So that's bevel. Now I want to talk about a problem with what I just did with these edges. So the idea is I want to support these structural edges, right? 1, 2, 3, and I added these loops. That's good and all, but can you see how we're losing some of that structural integrity? It's quite subtle, but if I turn on if I increase the number of smooth, you can see that when I press smooth, it actually starts to round here, right? In a weird way. Okay, it doesn't round nicely, like it doesn't go straight, round, straight, which is actually what you want. It goes kind of very haphazard, like it starts rounding from here, right? It starts rounding from here. And the reason this happens is because you have to think this edge is the only edge supporting these structural edges. So they have to average out the position between here and here, which is, even though this is a small cube, relatively speaking, it's a lot of distance to cover. So it's gonna create a bit of an awkward rounding. So how do we get around that? And you know, in some cases this will be okay, because you know, it might be from very far away that you're gonna see this, so you might not even notice this, right? But in other cases it might not, because we might need to see a very close-up shot, and we don't want the silhouette to be curved like this, curved in a weird way. So what we can do is to add another supporting loop here, here, and here. Okay, and now you see that this structural edge is holding way more nicely. And if you compare the left and the right, just pause the video, you will see the difference I'm talking about. It's quite subtle, but it definitely affects the look of the object. So does this mean you should always use 2 supporting loops? No, not at all. I'm just telling you that this is a phenomenon that happens with the 3D softwares, and most 3D softwares calculate smoothing in a very similar way, so you should expect this to happen in Blender, in 3ds Max as well. But no, I'm not suggesting that you add 2 loops to support every structural edge. I'm just saying sometimes you might need to do that if you want to achieve the ultimate level of precision, because adding loops comes with another set of problems as well. It adds more geometry, which is important for games, and it also makes it a bit more messy to work with. And we'll talk about that in later part of this video, and also in later videos when you should do what I just told you. But for now, I just want you to keep that in the back of your head, and in most cases just adding 1 supporting loop will be fine, even with the object that we filleted. You can see here that if I smooth, we also lose some of that structural integrity. Let me just change this a little bit. we also lose some of that structural integrity, right? We get rounding starting from way before the edge loop is in place. So the way we can resolve this is also by adding another set of structural edges, no, another set of supporting edges, I should say here. And this will help this cube hold its shape better, right? And you can see the difference afterwards. Didn't add it here yet, but you can see the difference afterwards, right? Pause the video if you can't, and you can definitely see there's a subtle but significant difference. So we talked about adding basic supporting edges. We talked about adding fillets. Now I want to talk about adding, a chamfer. So what we have here is a chamfer. So you can see that this is fully cut on the side. It's not a rounded smooth corner. And the way we achieve this is also by having our cube. And you can see I first filleted the corners here. So if I just select the corners, I bevel, increase number of segments, so let's say 4. And then, okay, I can add the chamfer, which is another bevel, but I don't add segments. Segments are at 1. And that's our chamfer. Okay, so now we have our structural edges, right? Because think about the definition of structural edges. If I remove them, they will change the shape of the object. So these are all structural edges. Like none of these could be removed. Once I have that, I can add my supporting loops, right? So think about it. This I need supporting loop. This I need supporting loop. So add edge loops here, here, here. Right? So these edges are now supported. Same for here. We have a supporting loop here. We want to support this, this, and this. So very nice. Okay, remember that this is also a structural edge, because if I remove this, the shape will change. So don't forget to add your supporting loops here as well. Cool. So now when I subdivide this model, it looks correct. It doesn't look distorted. And of course, you see how the top here, there's a giant N gone. And I did this, or just cut across here, and kind of optimize the triangles here. So I'll go into detail shortly, but just for now, we're talking about edge loops and supporting edges. So let's move on to cylinders. Cylinders, you can do the same, or you should do the same thing, because this is our structural edge. So if I remove it, the shape of the cylinder will change. Now, for curved surfaces, we don't want to add supporting loops to the structural edge that is causing the bend, right? Because what will happen is, if I try to add supporting loop here, it's gonna create a nasty crease. Alright, like I said, we don't want to add supporting loops to curved surfaces, or supporting loops to structural edges on curved surfaces. What we want to do is do it horizontal, across. So if my curved surface was going in this direction, and all my structural edges are here, then my supporting loop would go across like this. This is fine. This will not affect the deformation of this cylinder. I could add as many edges horizontally as I like, it will still be fine. So that's what I did here. Remember, if I just add one supporting loop, it will hold the shape decently, but not perfectly. Right, you can see a bit of a curve off here, especially if I remove removed all these edges, this would just smooth and create a not so ideal kind of deformation. So if I add a supporting loop here especially, that shape is going to hold much better. This is also why we want to make our geometry spacing relatively equal. What I mean by this, you see I used the multi-cut tool to cut in all these edges running across the surface. This will also help to hold the shape of the object more, because this right now only has to average out the smoothing from here to here. You know, it doesn't, if I removed all this, oops, it has to average out a much longer distance. So adding geometry to make your model relatively equal spaced is a very good idea and a very good habit that I want you to keep in the back of your mind as well. Adding chamfers to cylinders. You can also add chamfers to cylinders just like you do to cubes. Just select the structural edge here. Let's do it on this bottom face and just bevel. And if you want to make it a fillet, just add divisions. Usually 4 is good, and you will have your bevel. Okay, let's talk about number of faces for cylinders and what's a good guideline and how to think about it. So the minimum for a perfect circle is 8. Okay. If I extrude this, 6 will not give you a perfect circle, although 6 can sometimes be used for creating a detail that is not seen close up. And you can see 8 will give you a perfect circle. That is the minimum number of edges required. And I want you to think in terms of 4s. So 8, 12, 16, 20, 24, 28, 32, 36, 40 number of faces. So 8, this one's 16. I turn on this, you can see 16 faces. And here is 32. So these are the most common number of faces for cylinders: 8, 16, 24, 32, and 40. Usually 32 will work for most cases, but you can start with 24 and see what you get. Alright, let's move on to some examples where we are trying to optimize the geometry. So we have 3 examples here, and what happened here is there are 3 faces initially, 1, 2, 3, and I did this pattern and then it became 2 faces. So this will be very useful in the later examples where you see this pattern used a lot, right? It's used very often, even sometimes like this will happen. Where you got 4 to 2 as well, but this is 3 to 1. So what I did, if I can expand this. Is you're just cutting in a triangle, right? So what happened here? I went from 4 to 2, or 3 to 2. In this one, I went from 4, see here, 1, 2, 3, 4, to 2, right? And these are patterns that you will need to practice creating. So just create a cube, take the top face and create a plane. Add some divisions to the plane and then practice drawing these patterns, okay? So 4 to 2, 3 to 1, 3 to 2, and 4 to 2, and here I'm combining them both. You see this? It's a very similar pattern, right? 2. How many are there here? There are 6, and I made it 2. So you can think about combining these as well. But what's important is you familiarize yourself with these patterns, practice them, do it several times if you need to, and this will help you a lot when you're actually in the nitty-gritty of optimizing your 3D model. So let's talk about panel lines, how to create panel lines. It's a very important topic as well, because as hard surface modelers, there's going to be a lot of panel lines we will need to add. So I want to show you how to do it. First, I'll show you on a flat surface and then on a curved surface, which will lead me into the practice homework I want you to attempt this week. So we have our planes with divisions across them, and what I did is I took some edges that I wanted as my panel cut. Right, remember, you could even do a custom design if you wanted. You could even do like something like this, where it was curved already. Right, and then I beveled. Okay, and it split this panel line into a face in the middle. And with this bevel, I can adjust the thickness how I like. And this, you have to think, will be the structural edge, or no, it will be the supporting loop of your panel line. So I have this, and I can extrude this surface, or I could use my multi-cut tool and edge loop tool to add supporting loops here and here. So that's why I said this outer edge is your supporting loop, or the edge of your supporting loop. So once I'm happy with that, I will extrude, offset, create some thickness. This can create a bit of chamfer look to it, and extrude again. Let's just delete this for this example, these outer faces. Okay. See how I created structural edges here? 1, 2, here, here, and even this. So if I remove any of this, technically the shape of the object will change. However, if I smooth it, it still doesn't have that fidelity that I'm looking for. So I need to add my supporting loops. Where would I add it to support the structural edges? And now this looks better. So you can see the rounding does not smooth it so well. So what you can actually do is cut in more edges here and manually kind of create that smoothing that you're looking for. Okay, and of course this edge here, remember the pattern we were doing just now? This 4 to 2, 3 to 1, etc. We want to apply it here. And you see how I just turned 1, 2, 3, 4 into 2. It's the same thing, don't you see? So that's what we need to do. And you can see here we have this shape that is looking like a convex shape. So we don't really want quads that look like this, where one of the let me put it another way, where one of the edges are going in. We want it. So what we're gonna do here is cut it like so. And there's just this thing which we'll use the target weld tool to fix. And there we have our panel line. And you can see here, I have two examples of different ways the panel line is being added. So here, remember our cube example, where this is the structural edge, because if I remove this, it will collapse. So I'm adding loop here to support it. And what I'm doing for this corner, which is another pattern you need to familiarize with, is this. So you need to cut across here and cut a supporting loop in to the structural edges here. So remember this pattern as well. And there's another way to do our panel lines. It is to do what I just talked about, where you are rounding the corners yourself. And you can see how this inner side of the panel line here is a curved surface instead of square, and also having the edge loop like this. See the difference? One makes it more smooth, more rounded, one is more squarish, which is fine depending on what you want. And also the same rule applies here. The thinner that we make these supporting loops, the sharper our edges will be. As you can see here, I made it pretty sharp, and this might be what you want if you want a high-tech sci-fi look. Okay, let's talk about adding details to surfaces. Primarily circular details, and this pill-shaped detail I have here. So what you want to do is, I'll duplicate this here, is remember how I said for circle cylinders we need at least 8. You could do a circular detail with, let's say, just 6. So what some people do is they take this, they bevel it, or they bevel it, and you see how there's only 4 here. They will create a circular detail out of that. But know that it's not a perfect circle, but that might be okay if you're looking from a far distance. But doing it this way, you could also add these cuts to make how many edges? 1, 2, 3, 4, 5, 6, 7, 8. Which is a perfect circle. So if I circularize this, there is our perfect circle. Now let's create a circular detail. What we'll do is we'll take our circle, we can adjust the offset, the radial offset to make it bigger, smaller, normal offset to have it come out the screen. So let's do a combination of both. We have our radial offset, and I'll extrude it, create our supporting loop, right? Because all the structural edges should have supporting loops, if that was your intention. Extrude it again, and just created a circular detail that comes out. Now let's do something that goes into the screen. So we'll extrude, create our chamfer detail, extrude again, and for this we can do it like this, where we just cut across and we got a quad here. And then we add, remember what we do after we add our structural edges? We add our supporting loops. And boom, you have a nice circular detail. And you know, you could even mix things up and kind of combine them how you like. So experiment with these tools, experiment with what I've just told you. It's a lot to go over and practice, but just take your time and you will get used to it eventually. Now let's talk about how to create kind of inset details, how to create this kind of detail. So let's start with this pill-shaped detail. So what I'm doing is I'm selecting a set of edges and then I'm beveling it. Okay? And I'm adding two segments here. And I'm cutting the triangular corners like this. Okay, so this is technically our supporting loop, right? Or you could add your supporting loop like this. It really is up to your preference. Remember, we have to extrude this or make it go into the model. So let's make it go in, and we can scale it however we like to create this kind of chamfered look too. And you can see how very easily we're able to create a nice looking detail. And you could even take it and remember, this is our structural edge. So if I move it, it's going to collapse the shape. So I either adjust these edges to go closer, or I could cut in another set of supporting loops. Remember, I want to support this specific edge, so I'll make it consistent with that logic. See how it's holding that shape nicely? And let's keep it consistent here too. See the difference between the left side and the right side? So it's all about the kind of look you're going for as well. And just try to be consistent with that. Okay, let's talk about how to create. Let's talk about triangles and n-gons. Are they okay? Are they not okay? Well, let's be clear. Triangles are okay if they do not affect the structural edge and how the model looks when you smooth it. For example, see I have a triangle here and here, but that's okay because when I smooth the model, and since this is a flat plane, I'm not going to see any artifacts. The problem comes when we try to have triangles on a curved surface. So if I just cut this in here, you're going to see a little bit of artifact. Right? Not much, but a little bit. To make it more obvious. You can see a little bit of artifact here. So it's only when triangles are on curved surfaces that it creates a problem. You can see here, actually did still have quite a few triangles, but that's okay. Right? I mean, I could even do this to make it quads, but I don't have to, right? Because this is a flat surface, so any triangles will not be visible. That being said, I don't want you to go around modeling with triangles. Please keep it to like a minimum still, but I would say it is okay and perfectly acceptable. As for n-gons, I would recommend you do not use any n-gons in your modeling. And what n-gons are, if you do not know, is, at least for subdivision modeling, it's a surface with it's a face with 5 points, or 5 vertices. So 1, 2, 3, 4, 5. I recommend you do not model with any n-gons at all, even on flat surfaces. And let's just keep it at that. Because the reason I say this is different softwares will have different ways of treating n-gons, and they will render differently based on different softwares that you're using. So in order to maintain consistency as much as possible, we don't want any n-gons whatsoever in our 3D modeling. Okay, let's talk about the importance of having equal spacing when we're doing modeling. And you can see from some of these examples, and you will get this 3D file, I tried to maintain equal spacing between the polygons, right? And this will have twofold impact. It will allow us to solve the problem of having to use double edge loops if we just have enough edges to support to excuse me, for a base model. It also allows us to add details more easily. because I can only add a certain amount of detail here on this, whereas if I smooth it, which is the equivalent of adding more polygons, then I can add details, or I can add more fine details. So this is why we should try to maintain equal spacing with our polygons as much as possible. So when we're creating our structural edges, we want to try to add equal spaces to the polygons. Then add our supporting loops, and then we can add the detail. Okay? And I want to say as well, the mark of a good modeler is how well they can model curved surfaces. Because all these details are nice and it's fun to do and they're cool to look at, right? But the most difficult kind of models to make are the ones with very detailed curved surfaces, in my opinion. Angular models that you see online, a lot of them, they're not that difficult because they're just made up of boxes and spheres and whatnot, right? But when you add curved surfaces to mix, like a car, like a mecha with a very cool body shell, then that will increase the difficulty of your subdivision modeling significantly, which is what the car modeling process is for, is to help you with modeling set curved surfaces. So I want you to practice these examples here. Go through what I've showed you and experiment with details, either those you found online or of your own imagination. It's fine. I want you to really hammer in these points, adding proper supporting loops, optimization, adding panel lines, adding details. And now we're gonna talk about these topology exercises, which I want you to do. Alright, you don't have to do all of them, but at least pick a few that you think would challenge you and work on them. And I want you to approach it with the process that I talked about at the very beginning. Start with supporting edges, add more loops to make the polygons even, add supporting loops, and then you do your detail. Primary, secondary, tertiary forms. Okay? Think in that process. I'll send you this model and you'll be able to pick apart what came first, how do I approach it to get the best results. And if you're stuck, you can always refer back to the 3D model, because I'm not gonna mesh smooth them. I'm gonna leave them unsubdivided, and you can see how I solve certain topology challenges. Like here, this is a variation of what we talked about. 3 or 2 edges, 3 edges to 1, with a quad in the middle. And here, for triangles, how to do triangular corners. So I'll do a brief example so that you can understand what I've been saying all this while about the process, and then you can try these out on your own. And we'll go through your examples of what you've tried in next week's lesson. So I'm starting with a cube, and let's just create just use a combination of curved surfaces and flat surfaces. So I'm not really modeling with any specific idea in mind. I just want you to get familiarized with the process. So right now I'm just adding in the structural edges that I talked about. Let's say it's just some cool sci-fi detail of some sort, right? Once I have my structural edges in place, I want to think about adding the supporting loops, or making first sure that the geometry is even. So let's say I want this to be a smooth curve. I can work on doing that. Not spend too much time. I just want to give you the main idea that I'm trying to put across. Okay. Our structural edges, we've made it as even as we can. Now we can think about adding maybe add another loop here for now. Just smoothing this out, right? Okay, you know what? We'll leave it for now. We try to add supporting loops now. So our model's looking fine. We could make it a bit more even in terms of spacing. But for now, we're good to go. And also think about, this is a symmetrical object, right? I don't have to model both sides at once. I can just delete half, model on one side, and then mirror it to the other end. Okay? So, but I'll do both sides in this case to show you what I mean. So now I'm adding the supporting loops. remember, we don't want to add supporting loops to curved surfaces, like here. See here, it's creating a weird crease, so we are just gonna leave, this is just gonna be temporary. So we're gonna use this to fix it. See how it looks better now? There's this error here, which is fine. We'll just fix that really quickly. Okay, same for this side, right? These are just the common patterns that you need to practice and get used to. And you know, when you do a super tons of reps, you're gonna get very familiar with it, and it's just gonna be like second nature to you, you know? Trying to even out the polygons more, so that when I do add detail, it's going to be way easier. More like some kind of part from a car. Okay, but anyway, let's say our supporting loops are okay. Maybe we could add some here as well. For example, right? Okay, let's think about tertiary detail now. How are we going to add tertiary detail? Once we have our supporting loops in place, right? We went from structural edges, remember, to supporting edges, and yeah, I could spend more time fixing this. You know what? Let's delete half of this. It's easier to work on. just trying to fix the pinching here a little bit. And yeah, I could definitely spend more time to make the shapes fit better. But let's say we want to create a detail now. So we could find a surface that has sufficient amount of geometry. What we can do is we can do what we talked about. Like, let's say we want to create kind of a inset surface. Just grab create a extrude, push it in, and create something. So we select that. And our detail now has a structural edge. Right? So this is how you kind of use fractals to think about. Now we have this new structural edge, right? So what do we need to do? We need to add supporting loops to it, if that's what we want to do. So let's say we select all this, extrude, creating a supporting edge. Here we have to be careful about adding supporting edges here. You can see in real time how I'm solving topology challenges, and a lot of it is the basics which I talked about to you. And next week we're definitely going to cover more advanced stuff, and also about game modeling, how to work with that. Let's do the again. Okay. Even more detail here. Let's say I want to add a circle. Okay. So we add circles here. That's not what we want. And you know, we can do what we talked about previously with we got a cool circular detail. So I want you to apply that process I've been telling you about, and at first it's gonna be difficult, but then once you get the hang of it, it's gonna come more naturally to you, right? Like even here I want to maybe even out these surfaces a bit more and spend more time doing it so it doesn't look so sharp. You see here, because this is a flat surface, I can use a triangle and there won't be that much pinching going on. Alright, and I can just go on and on and on with details and whatnot. But I want you to think and apply this process whenever you're modeling from now on, especially in subdivision, because it will really help simplify and prevent you from getting lost in the details, essentially. Right? So apply this process to these shapes, or if you want to create your own shapes too, after trying a few of these, be my guest. And yeah, that's it for this video, and I'll see you in the next one.